So today we are going to learn about the first one is variables and second one is data types. Okay, then still we have a time, then we are going to learn about the operators.
Okay.
So these are three concepts we are going to cover today. So the first one is the variables. What is variable? So yesterday we have seen this one, int a equal to 10. Okay, now if we observe carefully, this is nothing but a terminator syntax. Now here we have these things, int, then a, then equal to, and finally 10. So here integer is known as data type. Simply I'm writing here dt. Then a is known as variable.
Okay.
So here this is variable. Now here equal to is known as operator. One type of operator it is. And this is nothing but value. Technically we are calling it as constant. This. So now there is nothing to discuss about the constant. So values, names or something, because those are treated as constants. Those constants we are initializing into the variable in this statement. Now to initialize that we are using this operator. So anyway we are going to learn about the operators after these things. So forget about these two things. Now we need to focus on variable, then data type. So first we see what is variable. So basically we can say what is variable in the sense. Variable is a name of memory. Variable is a name of memory. So technically what is happening here, when you enter in the a equal to 10, so a piece of memory allotted to store a value of 10. The memory name is nothing but a. So that we are calling as variable. Understood?
Yeah.
Right. So here, and the second point is we can change the value and variable at any time until you declared as constant. So there is a chance here you can declare a variable like constant by using const keyword. Now here I'm using int I equal to something value like 25. Again you cannot initialize another value here. Okay, now run this. You will get the alert. Must be a variable property or index. Okay, so until you declared as a constant, suppose if you remove this, then you can do I equal to 10. Got it?
Yeah.
So until you declared as a constant, you can change the value how you want at any point of time. And the third one is the value is available until you stop the application. So the value which we are storing, in the sense here the 10 is available in A until you close the application. So here run this. So the value is available in I. Once you stop, then what happens? Automatically there is a small concept, garbage collector. I will explain you later what it will do in a frequent time. I mean in a span of interval, what it will do, it will check the unused memory and it clears automatically. Okay, in traditional languages like C++, we need to dispose the object, we need to clear the object, but here no need that action. Automatically it will take care by the compiler environment. Simply the environment take care of the unused memory. So anyway, this value will available until you stop the application. So these are the 3 points you need to remember. What is variable in the sense you need to say this thing. Then we need to follow a set of rules when we are declaring the variables. You should. So what is variable? Not exactly variable, we can call it as identifier. So what is identifier? It's maybe a class name, it's maybe a project name, it's maybe a variable name, or it's maybe a method name. So when you are declaring any of these, then you need to follow these rules. The first one is should start with character. In the sense you can give like this int a1, it is valid, where int 1a is invalid. This is invalid. Got it? Now the second one is it can be alpha and numeric. In the sense, don't include any special characters, even space also, even white space. In the sense, as I mentioned earlier, you can declare like this. Otherwise, we have suppose my number, you can declare like this, my number 1 or something. But you cannot declare like this, my dollar number. It is invalid. At the same time, you cannot declare like this, my number. It is also invalid. Got it? But
Yeah, I got.
yeah, but underscore treated as a character. Treated as character. In the sense, you can declare like this, int my underscore number. It is valid. Or you can declare like this, int underscore my number. In the case of, actually here we cannot include the special character, but underscore is treated as a character. Remember this. And the fourth one is we cannot use existing use reserved keywords as identifiers. So what are the reserved keywords? So actually we have a set of keywords here. Okay, now here int is a keyword. So now you cannot declare like this, int. But here we have a keyword that is nothing but get. So that you can use here, because get has a specific meaning in a specific area only. So that's why here what we are saying, reserved keyword and contextual keywords. Two types of keywords are there. So now here integer is the reserved keyword and get is a contextual keyword. Like we have where also, where, yield, get, set. This set of contextual keywords are there. Those, if you want, you can use as a variable. But reserved keywords like int, if, while, these things, most of the keywords are reserved keywords. Those keywords you cannot use as a variable. In the sense, int if you cannot use, but int get we can use. So that is the thing you need to remember. And the next point is, still if you want to use reserved keywords as identifiers, So what I want to say here, so still if you want to use the result keywords as identifiers, what we need to do, we need to include that the red symbol before the result keyword. This is the way. So remember, including the special character is against the second point, but still in this case we can include that one. So this is the point you need to remember. And the last one is avoid case sensitive. Actually, it is not the rule. Already you know C# is the case sensitive, so int a equal to, or at the same time int capital A. You can declare the two types of variables with case sensitive. There is no problem. But in .NET we have a facility. We can use the C# code in VB.NET as well as VB.NET code in C#. So why I am adding this point is, in VB.NET it is not a case sensitive. In the sense, in VB.NET both are equal, but in C# both are different. So suppose if you are using this code in VB.NET, then there is a chance to get error. That is why I added here avoid case sensitive. And the final point is, don't use existing variable names identifiers. In the sense, here what I'm doing here, I'm declaring something like int name, again string name. Okay, it is an error because already we have a meaning for name. So here you are using the same thing again. Okay, so try to avoid the existing identifiers. These are the few rules we need to remember when we are declaring any identifier. So once again, what is an identifier? It may be a variable name or a method name or class name or project name. You should follow all these rules. So now we need to learn about the data type. What is the data type? So what is the need of data type? Because in real world we need to work with different types of data. So like sometimes we need to work with the numbers. Again, in numbers we have two types. One is with decimal and one is integer. And in strings, characters, and as well as we have a date time also. Like we need to work with the different types of data. To handle the different types of data, here we have the data types. Simply we can say what is data type of data, okay, which we are working with. So now there is no definition for the data type, but the thing is we need to remember this is the type of data currently we are working with. Now here also we have, coming to the C, we divide into the three categories. The first one is the basic data type, and second one is the derived data type, and third one is the user defined data types. Now in this session we are going to learn about the basic data type. So these things we are going to learn in future. So we focus on the basic data type only. Now what is basic data type? So usually we are working with some primitive type, like we can call it as a value type also, data types. So those are nothing but basic data types. So for example, coming to the numbers, we have two things. So simply I'm making here numbers. In numbers we have two categories. The first one is the integer. Again, in this integer we have four categories. The first one name. So what is that? 16-bit. Sorry, we start with the 8-bit first. So this is the 8-bit one. So how much memory it takes? So 8 bits in the sense, I think you know, it is equal to the 1 byte. So it occupies 1 byte. And it has a class name also. Class name. So known as short. Once again, so the first one is the 8-bit integer. It occupies 1 byte of memory, and the class name is byte, and keyword is the byte. So what is the difference between the class name and the keyword? So class name starts with the capital one, keyword all letters are in small case. In the same way, the next one is the 16-bit one, 16-bit integer. So 16 bits in the sense 2 into 8 bits. So it occupies 2 bytes. Class name is short. Keyword is short. Then 32-bit integer. So 30-bit in the sense 4 into 8 bits. So it occupies 4 bytes. Now here int 32. So short name is int. And finally 64-bit. 64 in the sense 8 into 8. So it occupies 8 bytes. Now it is known as long. Keyword is long. So by default, we are working with the int. In the sense here, the integer is nothing but a 32-bit. So what is the difference between these? Suppose here int I equal to 10. Now int I equal to 10. Both are storing the value 10 only. But it takes only 1 byte of memory, and it takes 4 bytes of memory. That makes a difference. So in these days, memory is not a concern. So that's why we are not focusing on rest of these things, 8, 16 or 64. Almost we are working with the 32-bit only. So by default, we are going with the integer, which is nothing but 32-bit. That is why yesterday here in this example, if you observe, we converted into the 32. So in the same way, we have different types of methods. What is that? 2 int 16 is there, 32 is there, 64 is there. Then what about 8-bit one? So already you know 8-bit one is known as byte. So we have a method like 2 byte. If you want to convert into the 8-bit, then you need to use this one. So anyway, by default we are using int 32. So that's why this. Okay, remove these things. So this is the family of integer. Then in this same way, we have the decimals. Decimals in the sense we have points. Okay, so it starts with the 32-bit only. Now coming to the decimal, here we have the first one is float. Float in the sense it is nothing but 32-bit. Directly we are working with the 32-bit. So 32-bit in the sense 4 bytes it occupies. Class name is float and the keyword is float. Then we have 64-bit one. So that is nothing but occupies 8 bytes. This is double. Shortcut is double. And we have 128-bit one, which occupies 64 into 2, so 16 bytes. This is decimal. Shortcut is decimal. So by default we are working with the double here. So it is 64-bit. Here the default one is the 32-bit. So when you want to work with any float values, then directly we are working with here double, then something I equal to some value. Okay, this is now by default 64-bit one. So this is about numbers. After numbers, we need to learn about the characters. Coming to the characters, we have two things only. The first one is the char and second one is the string. So now, what is char? Char in the sense it is 8-bit one. It occupies only 1 byte. Okay, class name is char and keyword is char. So this char can store only one value. Suppose hello is there. It is a collection of characters. How many characters? 1, 2, 3, 4, 5. 5 characters. I hope you understood. Character in the sense one digit, one number, one special character, whatever it may be. So only one it can store. So that is nothing but character. Now coming to the string. String in the sense technically it is character array, collection of characters. So we cannot judge how much memory it takes. The simple class name is string and the shortcut is string. For example, if you declare like string name equal to Ramu. Now here Ramu has 4 characters. So 4 into 8. Now it is 32-bit one. In the sense 4 bytes it allowed space in memory. So like we can judge about the string. We cannot judge initially how much space it takes. So char is there. Suppose what you need to do, char ch equal to, you need to write like this, c. So already yesterday also we have seen within the single quote it is character, within double quotes it is a string, and never you cannot give the value like this because it treated as a string. You cannot initialize string value into the character. Just keep this in mind also. Okay, apart from this we have boolean in the sense we need to work with the true or false also. So to handle that we have a type of boolean. So it is 8-bit one, occupies 1 byte, and the shortcut is bool, just bool, and class name is bool and shortcut is bool. So here just I'm going to declare this one bool b. This is, so it stores only true or false. Other than that it cannot handle anything. To store the true or false it takes 1 byte of memory. So other we have object type. So object type in the sense here also we cannot think about the memory or space. So here the class name is object and the shortcut is object. So basically this object is the base data type for all the respective and another data types. So object can hold any type of value. So what I'm saying here, so coming to the object can hold any type of value. So irrespective of data type, for example here object o equal to, you can give some string value, it takes. Later if you want you can store a number also, it takes. Any type it accepts. So technically object is the base data type for rest of the data types. That is the only difference. So now what about memory? Depends on the value it takes the memory. So here it is string. So now here based on string values it allowed the memory. Here it is the integer. So based on this it change the value. Okay. So anyway just remember object is the base data type for the rest of the data types. So these are the basic data types. All these are the classes. You can see the class names here: byte, short, int 32, long, float, double, decimal, char, string. Okay, all these are the classes. Classes in the sense, here, see, here we have the object. Again, here we have object. This is the class, that is a keyword, short name for the class. All these are available in system namespace. Remember, if you remove the system at the top, you cannot utilize these things. That's why we are including the namespace at the top. And apart from these, we have structures also. Structure in the sense, I hope you know the difference between the structure and class. So if you don't know, no need to bother about this. Later we are going to learn about these things. So now here date time, and we have a time span. These are the structures. So what is the use of this date time? So sometimes we need to work with the date times like joining date or date of birth or relieving date, something. Then this is the best way. Here you can see date time. This is date time D. This. There is no shortcut for the date time. Listen, because it is not the class, just it is a structure. In the same way, we have a time span. What is time span? Sometimes we need to calculate the difference between the two times. Then this time span will be useful to us. So these are the, usually we are working with these type of basic data types. These are known as basic data types. Now the next one is the derived data types. Derived data types in the sense, here we have arrays, collections. So before learning the derived data types, we need to learn about the conditions, loops. Okay, and then we come back to the derived data type.